Okay, let's talk about boxplots. Was it easy to draw the boxplot in the previous exercise? I think the only tricky point could be defining its quartile value. When there are even number of data points, the quartile point is between two values. And the most common way is averaging these two values to obtain the quartile values. So this may be trivial for you, but you may be completely unaware of it if you haven't tried to draw a boxplot by hand. And that's why I want you to draw a boxplot by hand. As mentioned before, the key idea of the boxplot is capturing and visualizing the basic summary statistics of the data. So what are the most basic summary statistics? I'll say maybe the median and the mean of the whole dataset. Median tells us where is the midpoint of the data distribution. Mean value also tells us the midpoint, but it can be swayed by outliers more easily than median. So once you identify where the median is, you know that each half of all data points is either side of the median. So it's really the midpoint of the whole dataset. So we draw a dividing line at the median in boxplot. Mean is usually depicted using a dot, but sometimes it's just omitted. And what would be the next thing that you want to know about the dataset? There can be many possible answers, but what we usually do is asking how widely the data is distributed. In other words, the width of the dataset. Does this dataset has huge variance, or is it tightly packed around the median? I think it's pretty useful to know about this, right? So the idea is drawing a box to represent the width of the dataset. So what do you mean by most of the data points, or width? Well, there may be many answers, but let's just say maybe the central half of the dataset, right? That sounds reasonable. So how do we know where to draw this box? Well, we just need to know where are the first quartile point and the third quartile point. Because the second quartile is the median, the fraction of data points that are located between the first quartile and the third quartile is exactly half of the whole dataset. Problem solved. So here is our box, ranging from the first quartile to the third quartile. This range is called IQR, or interquartile range, and captures the half of the data. So now we know where is the center, how the data is distributed around the center. Then what? The next thing that a boxplot tried to capture is more or less the full range of the dataset. But how can you capture the full range of the dataset? You know, if you have a large enough dataset, the range of the whole dataset can be stretched quite far, right? So indicating the full range of the dataset from the minimum to the maximum may be biased by the size of the dataset. Can we use something invariant? Can we indicate the range that roughly covers most of the data regardless of the size of the dataset? Well, you know, IQR roughly captures the width of the distribution, right? Then maybe we can use the notion of width to visualize the rough range of the dataset. Yeah, that sounds not bad. So why not stretching these two lines from the box using some factor of IQR? And this should be more or less independent of the size of the dataset. And if the distribution looks more or less normal, this should capture the rough range of the whole dataset. And let's call them whiskers. Then what should we do with the outliers that go over the range of the whiskers? Well, if the dataset is not crazy large, there should be only several points, right? So why not just show them as a dot, right? And that's the boxplot. So we have median value, mean, and the box that capture the width of the dataset, and then the whiskers that capture more or less the full range of the dataset, and the outliers that go beyond these whiskers. And that's the boxplot.